Again, when we consider the fifth problem, set the area enclosed by the parabola y square equals to 4x and x square equals to 4y. Use the method of integration to find its area. First of all, we have to draw the figure corresponding to the problem. Here, there are two parabola like this. The first one, y square equals to 4x, the parabola defines such that this is the parabola having vertex at origin and axis is along the positive direction of x-axis. So, defines here axis is along positive direction of x-axis. And if we consider the second, x square equals to 4y, which defines the parabola having vertex at origin and axis is along the positive direction of y-axis. So, we get the two parabola first. First of all, our task is that write the two parabola here, and our task is to find the points of intersections between the two parabolas. Such here in the figure O and P, we have to find the 2 points of intersection by solving these two equations given in the problem. Taking under consideration from one first, from one, which is taking under consideration, that is x equals to y square by 4. And if we substitute the result of x equals to y square by 4 in 2, what we get? Listen here. X equals to y square by 4, that whole square minus 4y. And if we proceed further for simplification, we get it as simply y to the power 4 minus 4 cube y, that equals to 0. And taking y as common, and we get it as y cube minus 4 cube, that equals to 0. And accordingly we get y equals to 0 a solution, and other is the y equals to 4. From here y equals to product of the two factors 0, y into this 0, so they must be separately 0. And when we consider y equals to 0, we get from here x is simply 0, and when we consider y equals to 4, from here we get x equals to, say, from here, say, simply 4. So these are the 2 points of intersections like this in figure. What they are O accordingly, respectively O 0 0 and P, which is 4 4. So these are the required points of intersection. Now here we have to define the actual area under consideration. What is that? The problem is here. Required area A, which is defined in the figure by this A, the shaded region. So we have to define it first. The required area A, which is shown here by the shaded region. How we get this shaded part? So first consider, as I defined earlier in the previous problem 4, area. First of all, area enclosed by the first curve, area enclosed by the parabola, first, by the parabola y square equals to 4x, comma, x-axis, and the straight line, and the straight line here in the figure x equals to 4, minus the area enclosed. First write the part, then we have to demonstrate. In area enclosed by the parabola, as I defined earlier in the previous problem, the first one, x square equals to 4y, comma, x-axis, and the straight line, and the straight line x equals to 4, the second area. So we have to define in figure 10. So what is that? The consider the area enclosed by the parabola y square equals to 4x, x axis, and the straight line x equals to 4. So consider that area enclosed by the parabola, the x axis, and x equals to 4. So this curvilinear area gives the first one, minus area enclosed by the parabola x square equals to 4y, x axis and x equals to 4. This gives this curvilinear area, another form. So if we subtract, we get this shaded portion. So if we define in it mathematics in definite integral, we get it as simply 0 to 4y dx, where the first one, where y square equals to 4x, minus 0 to 4y dx, where x square equals to 4y, where x square equals to 4y. So we have to form from these two, right? So from here y equals to 2 root x we get, and from here y equals to simply x square by 4, and we have to substitute these two results here. 0 to 4 2 root x first dx, minus 0 to 4 x square by 4 dx, and we have to proceed further under simplification part. So 2 which is constant, and here x to the power half dx, that gives x to the power 3 by 2 whole divided by 3 by 2. 0 to 4 minus again 1 by 4 which is constant, can be outside the sign of integration here, and then taking the integration x cube, simply this is x cube from 0 to 4. Now our task is to substitute the first the upper limit and then the lower limit as our usual formation, that is 2 into first 2 by 3 into 4 to the power 3 by 2 minus 1 by 4 into 4 cube, x cube by 3, there is a mistake, x cube by 3, 4 cube by 3, and here it is obviously 4 by 3 into the simplification. So 4 by 3, first of all 4 by 3 into 4 square root means 2, 2 cube means actually 8, minus here 16 by 3, and actually we get 32 by 3 minus 16 by 3, and finally the required result, that is the required area of this shaded portion, is 16 by 3. Since this is the area, it should have some unit, and this is the 16 by 3 square unit, and that ends the problem.